25 years, every player, every conversation, every ritual, every spin, every wish has had one thing in common.
Oh, sorry, didn't see you there. Today we'll be talking about the free throw, one of the most important shots in basketball. But you ask, how does the free throw relate to physics?
So how does a free throw relate to physics? We can use physics to calculate the initial velocity of the ball leaving a player's hand when the free throw is shot.
For John's uncontested free throw, we have a few givens. First, the length of the shot will be 15 feet from the shooter to the basket. Second, the time released from the shooter's hand to going into the hoop will be 0.7 seconds. And the angle John will be shooting at is 45 degrees.
First, we need to convert our feet to meters. For every foot, it is 0.3048 meters. So for our 15-foot shot, it will be 4.572 meters.
We need to find our horizontal rate, and as we all know, rate equals distance over time. So we're going to use x. We're going to use x as our horizontal rate, and then 4.572 meters is our distance over 0.7 seconds, our time, which will end up equaling, from our former calculations, 6.53 meters per second.
Now we need to count for our vertical rate. Since we get 6.53 meters per second, what we need to do is multiply that by the square root of 2, because our equation is involving a 45-45-90 triangle where the sides would equal a, and square root of 2. So what we do is we multiply those together and we will get the number 9.23 as meters per second as our final initial velocity.
Alright, now let's think real world here. The only time in a basketball game when you'll be shooting with no defenders on you is the free throw.
So we have to account for defense. When a defender is on you and they've got a hand up in your face, you have to shoot that ball at a higher angle to get it off without getting blocked.
Let's say around 60 degrees.
So our givens are going to be a little bit different this time. We're still going to have the 15-foot free throw, or when we convert it, 4.572 meters. But this time, our time's going to take a little bit longer because that arc is going to make it go a little bit longer to get to the hoop from the shooter's hand. So we're going to be at 0.9 seconds this time. And then the angle, of course, as we were saying, is now 60 degrees instead of 45.
So now we need to find the horizontal rate again. So we're going to use the same exact equation, except for instead of 0.7 seconds, we're going to put 0.9 seconds, which is going to end up equaling 5.08 meters per second.
Alright, now we need to account for our vertical rate again. So what we're going to do is we're going to use we're going to use a little bit different equation this time. This time, instead of having that 45-45-90 triangle, we're going to use a 60, because it's 60 degrees, we're going to use sine 60 of this. So what we'll do is, we'll have 5.08 meters per second, which is our horizontal rate, and then we're going to divide that by sine 60, giving us 5.86 meters per second as our final initial velocity for the shot coming out of the player's hand.
To me, it's easier to focus on the road when there's people screaming at you. When we play in Cameron and I shoot a free throw, it gets really, really quiet, and it's almost like a really eerie feeling. So it's a little bit harder to focus then. The one key to free throw shooting, I think, is the biggest key to shooting, period, and that's confidence.